Welcome to Lesson 7. So far we've reacted to alerts and remediated them safely. Now we shift the whole posture from reactive ticket handling to proactive and predictive operations. We'll detect anomalies and trends in endpoint telemetry, forecast failures before users ever feel them, and act early, all within the same guardrails we've built across the module. Let's frame the shift. Most support is reactive. A user reports a problem, you fix it. Proactive support acts on early but present signals before the user complains. The device is already throwing errors and you intervene first. Predictive support goes further left still. It uses trends and forecasts to act before any symptom appears at all. Every step to the left reduces user impact and cost, and AIOps is the engine that makes that leftward shift practical at fleet scale. Predictive work starts with seeing the shape of normal, then spotting deviations from it. KQL series functions do this directly. Make series builds an evenly spaced time series, here an hourly crash count over 14 days. Then series decompose anomalies automatically flags the points that break the expected pattern. Those flags are your early warnings, the moments where something is starting to go wrong before anyone has noticed. The real art is choosing leading indicators, signals that move before the user visible failure. On endpoints these include rising smart disk health warnings, which foreshadow drive failure, growing battery wear, which foreshadow sudden shutdowns, increasing crash rates, and repeated update failures, which foreshadow instability and blocked users. The key is that each indicator maps to a specific future incident and a specific proactive action you can take ahead of it. With trends in hand you can forecast, estimate when a metric will cross a danger line, and schedule maintenance before it does. Here we project storage growth and estimate when free space runs out. A forecast that free space hits 0 in 9 days is a maintenance ticket you schedule today, calmly, rather than an outage you scramble to handle next week. That's the whole promise of predictive support, turning future incidents into today's planned work. Here's the guardrail that defines safe predictive support. A prediction is a probabilistic risk score for humans to prioritize, not an automatic trigger. You feed the score into the same pipeline as before, it raises a recommendation, a human reviews it, and any consequential action still passes the approval gate from Lesson 6. Prediction moves the response earlier in time. It does not remove the human from the loop. That distinction keeps the whole thing safe. Because predictive systems act with less direct evidence than reactive ones, precision matters even more. A false positive triggers unnecessary maintenance, cost, and disruption to a perfectly healthy device, and a flood of false alarms causes alert fatigue that erodes trust in the whole system. So require a minimum confidence threshold, and require corroboration, several leading indicators agreeing, before you surface or action a prediction. Tune for high precision first, recall second. A system people trust is worth far more than one that catches everything and cries wolf. Let's see how predictive support sits inside everything we've built. Anomaly detection and forecasting find risk early. Those risk scores rank a human work list instead of firing actions. The approval gate and verification from Lesson 6 still apply to anything consequential. And confidence thresholds with corroboration keep precision high so trust stays intact. Predictive support isn't a new, riskier system, it's the same safe pipeline, pointed earlier in time. Let's recap. The journey is reactive to proactive to predictive, always trying to move left. You build anomaly detection and forecasts with make series and the series decompose functions. Predictions are risk scores that humans prioritize, never automatic triggers, and they pass the same approval gate. Your task: choose one leading indicator in your fleet, write a make series query over 14 to 30 days, and apply anomaly detection or forecasting. Define the confidence threshold and corroborating signal you'd require before raising a proactive ticket, and state which action it would recommend and why it still passes the approval gate. Next lesson is the capstone, you design the whole solution.